Hi again. Right now we're going to talk about some of our early CAD projects for our beginning kids. This is one of our CAD Mechanical 1 projects, and it's not so much a project as it is practice. We just have the students begin with some simple worksheets and moving from isometric or 3D viewing of objects to orthographic or multi-view sketching. We want them to be able to see the flat planes of an object, to be able to look at an object and draw it. Now, one of the items is we have them draw these 12 shapes. And what we have them do is we actually have them just sketch these shapes onto either some graph paper or just some blank paper or into their notebook. But it's all about learning to see the flat surfaces of the object. Like if I go through here and shade in everything that would be the right side view one way, and then come back in and highlight everything that would be in, say, the top view. On an object, and then say, okay, you're going to go in here and you're just going to sketch out those views. Well, what we want them to do is understand that you're projecting. I'm just going to throw that out of the way and just show you one of the examples we explained, that you're projecting off the views onto a flat plane and just showing what's on that plane. And then we explain to them that you will come back in, and we don't do this right off the bat. We tell them, explain to them that you come back in, and then surfaces that would be hidden from our views, we still include as a hidden line so that the viewer understands, yeah, there's information there that we can't see. We also show them how construction lines work, how center lines work, etc. So this is our end goal, is to have the students be able to see what's in 3 dimensions and how to project into a 2-dimensional surface. Now for that, like I said, I'm going to use those samples we just had up, and I'm going to put up just some graph paper, and we're going to, like I said, use these images here and sketch them out. We're going to do it quick and just basically so we can see what it is we're trying to accomplish. So mostly I usually begin and I just kind of divide my paper into quarters visually. I might go in and put in some rough lines just so I have some guidelines, and then I'll simply start and I eyeball it. So I'm going to start, I usually start with the front view being the one that's got the most information. In the example we give the students, I tell them, your front for the most part is going to be this. Now, in reality, a front view is always the view that shows the most information. But for what we're doing, this will be our front in all situations. This will be our right side, and we'll be coming at it from this angle for the top. So that's how we're going to start things. So I usually tell the students, we always start, like I said, quarter everything off. I just pick a spot to start down here, usually in the lower left-hand corner of my drawing area, and then I assign some sizes. So I'm just going to sketch out roughly what we'd see here. Well, I'd see something like this if I was drawing this thing out in 2 dimensions. And I don't get hung up on sizes so much as I just make sure all the information is shown in as near as possible a relatively simple, quick drawing. And it's just so I can communicate what it is I'm trying to see. Now, so there's my front view. My right side view of this, I can show them how I can project over from this, but it's going to end up looking like so. I'll just come over here and decide how wide it's going to be. I'm eyeballing most of this. And what kind of view I'd end up here. And like I'll have my holes cutting through it, my surface I can't see there going through, my holes going through there, my center line showing where that hole goes through. I'll come up here and make the top view, same process, I'll just project across. In this case, I'm, like I said, just eyeballing life. So I'm just kind of throwing it up here quick and not horribly concerned about how perfect it is, but that my proportion's right. I'll put in the center marks so that I can see where my centers are going to be, and that's what I'm trying to do. That's as simple as I can make it. Now, obviously this is quite small. I can draw it bigger if I want, but I need to draw it large enough that I can communicate what I see and I can just throw up my information quick and easy. So that's number 1. Number 2 for ours would look like this. I'm going to draw it a little bigger this time. And like I said, I'm just throwing stuff up. I'm just making it a very quick thumbnail sketch, just so I can communicate what it is the object is supposed to look like. I'm not getting hung up on details right now. This is just about learning to practice using my line types, my line weights, my information that I need to have. And basically it's not even really about the weights, it's just that I use the proper symbol in the right location. So when I come up here and I say, okay, well, this is going to be a square right there. This is obviously going to be a square right here. This will actually be connected from there to there. I'll have a piece that goes across like this. Another square back there, same size. Another square right here, same size. That'll go across. Those will close off. This will have the shoulder out here. This will have the shoulder out here. And then I'll have that hole going through the middle right there and put those in. That is literally what I'm looking for. Quick, easy communication so we can talk our way through all this. All right, so let's look at some more stuff here. Next piece looks something like this from the front view. Now this is a little different because what happens here is in the side view, I can see that it divides here in the middle. And then the back levels up, comes across part way and goes over. Here's the interesting part. If I go up here to the top view, I'm going to get something like this. So it's going to go up and over. It's got that shoulder right here, but it also comes out like this. And instead of being squared off, this is where we try to explain to students that rounded surfaces don't have an edge. It's where they disappear from view. Same thing's going to happen when I come back through the middle. That's going to come out here, curve off, come back over. Now, honestly, there should be a center mark in the middle of where that bore hole would be, because that'd be a bore and then usually a cut. But like I said, this is a sketch, so I come back up here, line up those things. If I want to, I guess I could put in a center line through there and a center line through here. And this should have a center line going out of it. But that's what we're trying to do. We're communicating information as quickly and efficiently as possible. This next one, like I said, we're just going to go quick and easy with this. I'm just going to throw it out here. It's going to look like this on the bottom. Okay, so we'll just throw that out. The next piece is going to come up, over a little bit, down like so, and then it's going to have a piece that sticks up like that. This actually has a hole that goes through it here, and there's two holes in the base piece right here and here roughly. Put center marks on those and center mark on this one. So up here on the top view, it's going to look something like this. It's going to come back across. The front actually sticks out farther, comes across like this, over, has this piece that comes out like so. And probably not actually that far, but right now I'm not horribly concerned about that. And then in the right side view, I'd see this. I would definitely see a piece that comes up like so, and then it's going to go up and over like so, and back. I got the holes that cut through it here, and they're in parallel, and then the hole up here that cuts through, and the center line there. So that's usually what I'm looking for. I'm not looking for details. I'm looking to communicate so that I have some sketch or some graphical information to explain to students, just basically get them thinking and how to sketch out their stuff. That's a third of the stuff we need to do done here. Now, one of the things we need to make sure we emphasize is that when we have an inclined plane, like so, that inclined plane, so those are hidden lines right there, supposedly. Like I said, this is quick and dirty sketching. It's not meant to be detailed or even horribly accurate, just proportional. That when I make that plane over here on the right side view, I actually won't be able to see anything that tells me that's a plane from this view except for this angle in the front view. Other than that, it's that L shape right there. And the holes will actually go through it here, but it's just an inclined plane. It just looks like a backward L shape to me here. Now on the top view, same kind of situation. This is going to come out like this, and it goes all the way out here to the front edge, and then all the way back like so. But right here, where I project up, that's where that notch is going to come back to. And it's going to proceed back until it lines up with that one. And then we've got different surfaces. So if I'm detailing this, this becomes my surface A here. Well, A in this view is right there. This becomes my surface B. Well, B in this view is here, and it's flat to me, but it's right here. I can see it in this one. C is this one up here on the top. Well, it's also up here on the top here, but I can't see it, but I can actually touch it there. So that means right here where the holes are, and I'm just going to eyeball them off that. That'll be my D there. Well, D here is actually right down there because this surface here is E. E actually becomes that one, or E is this one in this view. So D actually is down there to us. So my students have to be able to understand how the different surfaces relate. And that's what we're trying to make them do. It's, again, we're learning to understand that if I start sketching, my shapes need to agree with themselves. They might have something hidden from my view here. They might have something hidden from my view there. And they might have a piece that sticks out funny. Or if I look at it a different way, I might have a channel that goes through right there, and I need to erase this line right here. It might stick up like so, and come across like so, and then have this piece that's a solid block, and let's say I put a dimension in here. Well, what happens when I have a hole that ends in a blank surface right there? I can't actually see that hole, but it's still there. I'd have to be able to see that hole in the plan view, if you understand what I'm saying, and that these surfaces have to line up, which they should, and my holes go there. And I'm communicating the overall shape of the object right now. I'm not getting specific. This is rough concept sketching.
Hey.
All right, so there's our first half of this. And so far we've gotten through all these. We'll finish up these other ones in just a moment, but it's the same process as we've been doing. And then we'll show you the final product. Okay, that's it. Like I said, they're meant to be fast, quick, not really finished sketch, but it's just enough to communicate the information and just enough to project out so the students or whoever they're talking to understand how to make a quick sketch and go from an isometric view, such as we have here, projecting out to a flat view and create an orthographic or multi-view type projection. So that's where we're at with it. That's what we asked our students to do. It's not meant to be hard or difficult. It's just meant to start thinking graphically. Thanks for your time.